This is the first video in our React Native series on how to build the functionality for Weather app. Let's get into it. 1. Setting up the project. First, you'll need to set up a new React Native project. Make sure you have Node.js, npm, and React Native CLI installed. This is a crucial step as it lays the foundation for the entire application. Without this, there is no application to build on. Open your terminal or command prompt and run these commands to create a new React Native project named Weather app. This command utilizes the React Native CLI to scaffold a new project with all the necessary files and dependencies. Once the project is created, navigate to the project directory. Since the requirement is to build the app for iOS, you can start the iOS development server and run the app on an iOS simulator. This command will compile the code and launch the iOS simulator, displaying the default React Native welcome screen. Here's a brief overview of the main directories and files you'll find in your project. Android, iOS, source, app.js. Why this format? Using the official command line interface or CLI ensures that the project is set up with optimal configurations and follows best practices. iOS targeting. Since the focus for this tutorial specifically for iOS, we're focusing on iOS-related commands and directories. React Native allows for cross-platform development, but targeting a single platform can simplify development and testing. With the project set up, you're ready to move on to implementing the core features of the Weather app. Now we'll focus on getting the user's location, which is essential for fetching weather data specific to the user's current position. Getting user's location first requires us to install the geolocation library. We'll use the React Native geolocation service library to access the phone's location. This library is preferred for its accuracy and better performance. Install this command. If you're using a React Native version below 0.60, you'll need to link the library manually. For React Native 0.60 and above, auto-linking should take care of this for you. You'll need to request permission to access the user's location. In your iOS project, open the info.plist file and add these keys. These keys provide a description that will be displayed in the permission dialog. Searching for city or coordinates. Choosing a weather API. To fetch weather data, you'll need to use a weather API. Open Weather Map is a popular choice, and you can sign up for a free API key on their website. Here's a function to fetch weather data by city name. Similarly, you can create a function to fetch weather data by latitude and longitude. Pause here to read and understand the code. Implementing a search component. You can create a search component with an input field to allow users to enter a city name or coordinates. Here's a simple example. Separate functions for city and coordinates. By creating separate functions for fetching weather by city and coordinates, the code remains modular and easy to maintain. Async await syntax. Using async await makes the code more readable and allows for easier error handling. Simple search component. A basic search component with an input field and button provides a user-friendly way to search for weather information. Pause here to read and understand the code. With the search functionality in place, you can proceed to fetch and display the weather data, including graphics to represent the weather, handling units, and showing rain and humidity. Once you've fetched the weather data using the functions from the previous section, you'll need to parse it to extract the information you need. Here's an example of how you might structure the parse data. When working with APIs, it's essential to handle potential errors. You can add error handling to your fetch functions like this. You'll likely want to store the weather data in your component state so you can easily display it in your UI. Here's an example using React's useState hook. Parsing the data. Parsing the data into a well-defined structure makes it easier to work with throughout your app. It allows you to isolate the logic for extracting the data you need, making your code more maintainable. Error handling. Proper error handling ensures that your app can gracefully handle situations where the weather data might not be available, such as if the user enters an invalid city name or if there's an issue with the weather API. State management. Storing the weather data in your component state allows you to easily use it to render your UI, and React's built-in hooks make this straightforward. With the weather data fetched and parsed, you're ready to move on to displaying it with graphics, handling units, and showing rain and humidity. Now that we have the weather data, let's move on to where we'll focus on displaying the weather information with graphics. Installing SVG library. We'll use the React Native SVG library to create custom graphics for different weather conditions. You can create SVG components for different weather conditions. Here's an example of a simple cloud icon. You can create similar components for other weather conditions like sun, rain, etc. You can create a component to display the weather information, including the appropriate icon based on the weather condition. SVG for graphics. Using SVG allows for scalable and customizable graphics. You can easily adjust the size, color, and other properties of your weather icons. Modular components. By creating separate components for different weather icons and a main weather display component, the code remains modular and easy to maintain. Dynamic rendering. Using a function to render the appropriate icon based on the weather condition allows for dynamic and flexible rendering. With the weather information displayed with graphics, you can proceed to handle units, metric, imperial, and show rain and humidity details. Now we'll focus on handling units, allowing the user to switch between metric and imperial measurements, and defaulting to the units relevant to the current location. Determining default units. You can determine the default units based on the user's location. For example, you might use metric units for most countries and imperial units for the United States. Here's a simple function to determine the default units. Most weather APIs, including Open Weather Map, allow you to specify the units in the request. You can modify your fetch functions to include the units. You can create a toggle in your UI to allow users to switch between metric and imperial units. Here's an example using React's useState hook. You'll need to display the temperature and other values in the appropriate units. You can use the unit state to determine how to display them. User-friendly. Allowing users to switch between metric and imperial units provides a better experience for users in different regions. Dynamic default units. By determining the default units based on the user's location, you make the app more intuitive and localized. Modular code. By handling the units in a consistent way throughout your code, you make it easier to maintain and modify in the future. With the units handled, you can proceed to the next section, where you'll show rain and humidity details. Moving on now, to where we'll focus on displaying rain and humidity information. Since you've already parsed the humidity data from the API response, displaying it is straightforward. You can include it in your weather component. Rain information might be provided in different ways, depending on the weather API. For example, Open Weather Map provides rain data for the last 1 hour. If you want to represent rain graphically, you can create an SVG component similar to the weather icons you created earlier. You can include this icon in your weather component based on the rain data. Clear information. By displaying both numerical data and graphical representations, you provide a clear and engaging overview of the weather conditions. Conditional rendering. By using conditional rendering, example only showing the rain icon if there's rain, you make the UI dynamic and relevant to the current weather. Consistent design. By using similar techniques to display rain and humidity as you did for other weather information, you maintain a consistent and cohesive design. With the completion of this section, you have implemented all the core features of the weather app, including using the phone's location, searching by city or coordinates, fetching weather data, displaying it with graphics, handling units, and showing rain and humidity. Throughout this tutorial, we focused on best practices such as modular code, error handling, user-friendly design, and efficient data fetching. These principles not only apply to this specific project but can guide you in other React Native development as well. In this video we've learned how to build the functional elements of a weather app. But we didn't cover the design and layout of the user interface, UI. Designing the UI is a crucial part of app development, as it directly impacts the user experience. To continue this, you'll need to call on the following. User flow, map out the user flow to understand how users will interact with the app. Key features, identify the key features that need to be highlighted, such as current weather, search functionality, and settings for units. Wireframes, create wireframes to outline the basic structure and layout of the app. Prototypes, develop interactive prototypes to visualize the user interactions and transitions between screens. Weather display, design the main weather display with clear visuals for temperature, weather conditions such as sunny, rainy, and so on. Search component, design the search component with an intuitive input field and button. Settings units toggle, design a toggle or settings area for switching between metric and imperial units. Color scheme, choose a color scheme that aligns with the app's theme and ensures good readability. Typography, select fonts and text styles that are consistent and easy to read. Spacing and alignment, ensure proper spacing and alignment for a clean and organized appearance. Adaptation to different devices, design the layout to adapt to various screen sizes and orientations. Testing on multiple devices, test the design on different devices to ensure a consistent appearance and functionality. User testing, conduct user testing to gather feedback on the design and usability. Iterative design, make iterative adjustments to the design based on user feedback and testing results. Designing the UI is a multifaceted process that requires careful planning, creativity, and attention to detail. By focusing on the user needs, creating wireframes and prototypes, designing individual components, applying styling, and ensuring responsive design, you can create an engaging and user-friendly interface for the weather app. If you'd like more specific guidance on any of these aspects or examples of how to implement them in React Native, please reach out to us at Enigma Consulting.